What's up, you freaking geniuses? So in this video, I'm going to go over a couple system of equation word problems. All right, so let's start with this one right here. So this one says Batman is 26 years older than his beta son Robin. The sum of their ages is 69. Find their ages. Okay, so we obviously don't know Batman's age or Robin's age, right? So since we don't know those, we can just abbreviate those with a variable. So Batman, we'll just abbreviate with a B, and Robin will abbreviate with an R. Okay, so we're just trying to find relationships between their ages, Batman and Robin's ages, right? So here's a relationship. It says the sum of their ages is 69. So that means if we add Batman's age to Robin's age, it would add up to 69. Okay, so B plus R, right, Batman plus Robin's age, is equal to 69. Okay, cool. So we just found one relationship, but in order to solve for two variables, we need two equations. Okay, so we need to find one more equation, one more relationship. Okay, so let's go back to this first sentence. It says Batman is 26 years older than his beta son Robin. Okay, so this means Robin's age plus 26 should give us Batman's age, right? So Robin's age plus 26 years is equal to Batman's age, okay? So we have two unknown variables, right, B and R, and we have two equations, okay? Now, when you have two equations and two unknowns like this, you're either going to have to use the substitution method or elimination method to solve for each variable, okay? And in this video, I'm going to use the substitution method. And if you're not familiar with what that is, I'll link a video to that in the card above. But basically, you just have to solve for one variable in one of the equations and then just plug it into the other equation that you have, okay? So for example, here in the second equation, we already have it solved for one of the variables, right? We have it solved for B because it says B is equal to R plus 26. So since we know what B is equal to right here, we can just plug in this, R plus 26, right, because that's what B is equal to, and plug it into the other equation for this B, right there. Okay, so let's do that. So we're going to plug in R plus 26 for this B right here. So R plus 26, and then the rest of the equation is plus R is equal to 69, right? Plus R is equal to 69. Okay, so now this is a little easier to solve for, right? So now we can just combine like terms. So R plus R, that's equal to 2R, right? And then we have this plus 26, and then it's equal to 69, right? Equal to 69. Okay, so in order to solve for R right here, we need to first get rid of this 26, and I'm going to do that by subtracting 26. And what we do to one side of an equation, we do to the other. Okay, so then these 26's cancel out, and we're just left with 2R is equal to 69 minus 26, and that's equal to 43, right? Yeah, 43. Okay, so in order to solve for R right here, we need to get rid of the 2, and I'm going to do that by dividing by 2. And what we do to one side, we do to the other, right? So then these 2's cancel out, and we're just left with R is equal to 43 divided by 2, which is equal to 21.5, okay? So we just found Robin's age here, right? Robin's age is equal to 21.5 years, right? 21.5 years old. Okay, so we figured out Robin's age. Now, how do we figure out Batman's age? Well, all you have to do is, since we know what R is equal to now, right? It's equal to 21.5. All you have to do is plug in 21.5 for R in either one of these equations. Doesn't matter which one. Let's just use this second equation, okay? R plus 26 is equal to B, okay? R plus 26 is equal to B. Okay, but now we know what R is equal to, right? It's equal to 21.5. So let's plug in 21.5 for R. And then the rest of our equation right here is plus 26 is equal to B, okay? So 21.5 plus 26 is equal to 47.5. So 47.5 is equal to B. Okay, so now we just found Batman's age, right? 47.5 years old. Okay, so hopefully that wasn't too bad. Let's try one more example. Okay, so here this problem says the movie theater sold 147 tickets to the newest Marvel movie for $1,302. Adult tickets are $11 and children's tickets are $8. So, how many adult and children tickets were sold? Okay, so again, all we're trying to do is find relationships, right? So, the first thing it says here is the movie theater sold 147 tickets, okay? So, some of those were adult tickets and some of those were children's tickets, right? But we don't know how many of each one. All we know are adult tickets plus children's tickets is equal to 147 tickets, right? Because that's how many total tickets were sold, okay? So we just found one relationship right there. Okay, what other piece of information do we know? So it says the theater sold 147 tickets to the newest movie for $1,302, right? So that's the total that they sold it for, okay? And it also says adult tickets are $11 and children's tickets are $8. Okay, so let's ignore the fact that there's two different type of tickets right now. Let's just say that there was one type of ticket and that they all cost just $11, okay? Now, if each ticket is $11 and they sold all those tickets for a total of $1,302, how would we be able to figure out how many tickets they sold? Well, the way you would figure that out is, okay, $11 times the total number of tickets would be equal to $1,302. Okay, but we do have two different type of tickets, right? We have adult tickets and children's tickets. So the adult tickets are $11, right? So we can say 11 times the total number of adult tickets, right? And that would give me a certain total, right? Not necessarily 1,302 because that's the total for the adult tickets and the children's tickets together, but it would give me a certain total. And the children's tickets are $8, right? So we would take 8 and multiply that by the total number of children's tickets. Okay, so we know that a combination of adult tickets and children's tickets would give us a total of $1,302, right? So we can simplify this a little bit. We can write 11 times A, or just 11A, and then we can add, right? We're adding the children's tickets, 8 times C, or 8C, and that's going to be equal to 1,302, right? 1,302. Okay, so now that we have two equations and two unknowns, right? The unknowns are A and C. Now we can solve these using either the substitution method or elimination method. And since I already did substitution in the first problem, let's do elimination right here, okay? Now the way elimination works is you're trying to make one of your variables disappear or cancel out. So you either want the A's to cancel out or the C's to cancel out. Okay, so for example, since I have a positive 11A down here, I would need a negative 11A up here for those to cancel out. Or since I have a positive 8C right here, I would need a negative 8C up here for the C's to cancel out. Okay, so in this example, let's just make the C's cancel out, okay? So if I need a negative 8 right here at the top, that means I have to multiply the whole equation by negative 8, okay? And then you just take this negative 8 and basically distribute it, or you just multiply it by every single term in here, okay? Including the number at the end, right? Very important, don't forget that, okay? So rewriting this, negative 8 times A, that would be negative 8A, right? Negative 8 times C would be negative or minus 8C, and then that'd be equal to negative 8 times 147, which if you plug that into your calculator, you're going to get negative 1,176. Okay, so since we just changed this equation, we can basically just kind of ignore that now. So these are the two equations we're going to be working with. And all you have to do now is add these together, okay? So first of all, here, 11A minus 8A is equal to positive 3A, right? And then here, positive 8c and negative 8c, those just cancel out, so we don't have anything here. So then this is equal to 1,302 minus 1,176. And that is equal to 126. Okay, so then down here, we're just left with 3a is equal to 126, right? So in order to solve for a right here, I'm just going to divide by 3 on both sides, okay? And then these 3's are going to cancel out, and we're just left with a is equal to 126 divided by 3, which is equal to 42, okay? So we just found the number of adult tickets, right? We have 42 adult tickets, right? So how do you figure out how many children's tickets we need? Well, all you have to do is plug in your a right here, 42, into one of the original equations, okay? And I know I kind of scratched it out, but this was one of the original equations, right? A plus c is equal to 147. So you could either plug it into this equation right here or this equation right here. And obviously this first one looks a lot easier to work with, right? So let's plug it in right there. So just bringing it down, a plus c is equal to 147, right? But we now know what a is equal to, right? It's equal to 42. So let's plug in a 42 for a right here. So now we have 42 plus c is equal to 147. And let me scroll down a little bit. Okay, so then solving for c right here, we're going to get rid of the 42 by subtracting 42. And what we do to one side, we do to the other, right? So these 42's cancel out, and we're just left with c is equal to 147 minus 42, which is equal to 105. So that means there's 105 children's tickets. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.